Guys, welcome to another video here. We're going to be doing let's see what's up new today. We're going to be doing special right triangles. That's the main lesson that we're going to focus on today. This could be easy for some students, but it could also be a little bit challenging. It's hard to see at first, okay, but we're going to be doing a bunch of examples so you can tackle those. We'll also be working about, we're going to be doing SOHCAHTOA as well today. We're going to start with the easy ones today though, easy problems. Okay, so let's go ahead and get started. I'm going to be reviewing some problems for you. I'll start with number 1. This is something that we've seen since the first day. This is like the first thing we saw, and we're still doing it because I just want to make sure that you are able to do it very well. Okay, so this has to do with creating an equation that is related to this segment right here. Okay, so it says that from here to there is x minus 4, and then from here to there is 13. But the whole thing from here to here, that's 3x minus 9. So I could set up an equation like this. I could say x minus 4 plus 13 should equal 3x minus 9. Okay? And then all we have to do now is...
Okay.
Oh, sorry about that. My Siri started talking for no reason. Let me shut her off. And let me also pull up the... Okay, so let's keep going. We're going to add those two together. We're going to get x plus 9 is equal to 3x minus 9. We're going to go ahead and subtract x on both sides. And then I'm going to get 2x is equal to, let me actually add 9 on both sides now, so that this and this cancels out. We get 18 there. All I have to do now is divide by 2 on both sides, and I get x is equal to 9. Okay, so be careful of what the question is though. If you look at this question here, it says to find ln. Okay, so one of the things that I have to do to find ln, so all of this right here, would be to plug in that 9 into there right there. So that would be 3 times 9 minus 9, 3 times 9 is 27, minus 9 will be 18, and that is your final answer. That is what you have to answer. So you don't only have to find x, you also have to find ln. You're going to do the same with number 2, okay? So make sure you give that one a try. All right, this one here, we also learned, these are what we call proportional triangles here. So here's how we're going to do them. Very simple. We know that this, it's kind of proportional to this, and this right here will be proportional to this right here. So there's different ways we can set this up. I'm going to set them out like this. I'm going to set 22x minus 11 over 21 is equal to, okay, if I started with this one here, now I'm going to start with this one here, 10 over 14. I could simplify that fraction to make it simpler. This one, I mean. Yeah, let's do that. 10 over 14, I could divide by 2. Then I get 5 over 7. Then let's go ahead and cross multiply now. I'm going to cross multiply now. So that means that I'm going to multiply 7 times that and 7 times that. That's going to give me 14x minus 77 is equal to, now let's go ahead and multiply 21 times 5. Okay, let me actually pull out my calculator, although that should be 105, I believe, but let me just verify. Now 21 times 5, I always use a calculator because I like to be sure of what I'm doing here. Add 77 on both sides here. Okay, so we're going to add 77. That's going to give us 182. And then you're going to divide by 14 on both sides. And that's going to give you x is equal to 13. Okay, and that is what our answer should be for that one. Number 4 is actually very similar. You do need to find this right here from here to there. That's very simple. What you have to do is subtract 22 minus 6. Okay, so this will be proportional to this, and this will be proportional to whatever you get there. Okay, all right, let's keep going. Number 5. Very simple. We know that all of this has to add up to 90 degrees. Those are what we call complementary angles. Complementary angles are angles that add up to 90 degrees. Okay, so we're gonna take this one here. It's 6x plus 3 plus x plus 17. That has to be 90. 6x plus x is 7x. We got this 3 plus this 17. That's gonna be 20. Okay, subtract 20 on both sides. You get 70. When you divide by 7, you get 10. Okay, all right. Number 6, very similar. All you have to do now is that all of this will add up to 180 degrees. Those are what we call supplementary angles. Okay, supplementary angles are two angles that add up to 180 degrees. Okay, as you can see in number 6. Okay, we also learn about isosceles triangles. Isosceles triangles are, are triangles that have two equal, or they have two congruent sides. Okay, so if those two are congruent, then this and this is also congruent. So if this is x, this in a way will also be x. So we could actually set up an equation to figure out what x is. It will be 2x, because we have two x's, plus 40. That should add up to 180. Subtract 40 on both sides, and then you get x is equal to 70 degrees. Okay, number 8 is actually pretty easy, because you know that all those are going to be the same, so x should be very easy. You will see that it's very easy. All right, number 9. Number 10, just to let you know, this and this are always congruent, so that's how you solve that one. This one, they're vertical angles. Vertical angles are congruent as well, so we know that 6x minus 10 is equal to 50. Add 10 on both sides, you get x is equal to 10. Okay, so some of these problems you can actually do them pretty fast. All right, let's do number 11. These are the ones that are a little bit more challenging and require a little bit more work to do. Okay, so in this one here, the first thing I want to do, well, first of all, I need to figure this out. But in order to figure that out, I have to figure a lot of things out. Like, for example, I gotta know what this is right here. So how do I know that? Well, I'm going to subtract 180 minus 114 to get that right there, because I know that those two add up to 180. Okay, so when I subtract there, okay, 114 minus 180 minus 114 should be 66. I know that these are isosceles triangles, so I know that this and this are congruent, so those two are the same. So here's what I'm going to do. I'm going to subtract 180 minus 66. Okay, because those two are congruent, I'm going to divide 114, which is what I got, and divide that by 2, and that's going to give me 57 for each one of them. That means that this also is 57. Okay, you can see that this is congruent to this right here. So that means that this is also 57. So if those two are 57, and I know that all of that adds up to 180, I know that 57 times 2 is 114, okay? Which means, this is very interesting, that when I subtract 180 minus 114, I should get 66, okay? That, that worked out very nice. So that 2 is 66. So that means that this right here is 66. So I know that 66 minus 6x plus 6x minus 6 plus 6x Let's add 6 on both sides. We get 72. And then 72, when I divide it by 2, when I divide it by 6, that should give me 12. Okay? All right, very good. I'll have you do number 12 for me. All right, number 13, we're being asked to simplify radicals here. So when I look at radicals, I always think about the perfect squares. Perfect squares, I always like to list them. I have 1, 4, now 3 square is 9, 4 square is 16, and we have 25, 36. Those are all my perfect squares, okay? So I want to see which number divides 128. So I'm gonna check, let's see, I'm just gonna use those right there. I'm gonna check 16 or 128 divided by 16. That doesn't work. How about 128 divided by 9? That doesn't work either. 128 divided by 4. Okay, that seems to work. Let me see if I can find a bigger one. 128 divided by 36. That doesn't work either. And let me try and then you know what, guys? 64. I'm missing 8 times 8. 128 divided by 64. Guess what? That's 2. Okay, so that's what we have to do. So I always try to find the biggest one because that's going to help you figure this out a lot faster. So I can divide this as 64 times 2. 64 times 2 is 128. And I can break this up like this. Okay, the square root of 64, we know that that's 8. And then we have that 2 on there. Okay? So that's how you solve number 14. All right, this one here, we kind of talked about this one as well. And let me actually pull it up really quick here. I know that something is a right triangle if a squared plus b squared is equal to c squared. That's a right triangle. Okay? Now I do have to try to remember. And I'm going to look it up really quick here. And this is called the converse of the Pythagorean theorem. If you go on pictures, it will tell you. So let me actually show you how I'm looking this up. I just realized my charger wasn't working. All right, I always have a problem with my, okay, so if you type in converse there it is, converse of the Pythagorean theorem. There's many images. This is the one I always use. Okay, if c squared is less than a squared plus b squared, then we have an acute triangle. Okay, so if c squared is less than a squared plus b squared, then we have an acute triangle. And then the other way around, then we have an obtuse triangle. Okay, this is what we call the converse of the Pythagorean theorem. Okay, so we're gonna check this now. We're gonna say, well, this right here is my c. That will always be the c, the last number. So we have 16 squared, and then we have 12 squared plus 5 squared. So let's go ahead and check that. So 16 times 16, that's going to be 256. And then we have 12, 12, 12 times 12 is 144 plus 25, which is 5 squared, is 169. Okay, so as you can see, this is bigger than that. So if I match this, this will be an obtuse triangle. Okay, so that's how I find that answer. I don't always remember what it is, but I always can look it up. It's the converse of the Pythagorean theorem. Okay, as long as you look it up, you will be fine. Or write it down. Okay, find the missing triangle. This is what we use. We use the Pythagorean theorem here. So we know that, you know, if this is A, and this is B, and this is C, then we have 3 squared plus x squared is equal to 5 squared. Okay, I'm pretty sure this one is going to be 4. And yes, it is 4. Okay, so we use the Pythagorean theorem on this one as well. All right, on number 19, those are a little bit more challenging problems because I'm asking you to find the area of that, okay, of that triangle. And it is challenging, but it's not impossible. As you can see, we have a right triangle there. So in order to find the area of a triangle, I know I have to multiply the height times the base. Okay, so I don't know what the height is yet. We have to figure what that is. Okay, but we can use the Pythagorean theorem in order to figure out what the area or what the height is. Let's say that this right here is h. Okay, so that means using the Pythagorean theorem is that h squared plus 5 squared should equal 11 squared. So now we're going to use the Pythagorean theorem now. Oops. This will be 25. This will be 121. Subtract 121 minus 25. That gives you 96. And I'm going to take the square root of 96. And that's going to give me h is equal to 9.7979. Okay, so I'm just gonna say it's 9.80. Okay, so this right here will be 9.80. All right, so now I'm going to go ahead and use that 9.80 to figure it out or to solve this triangle right here. What do I mean by solve that triangle? Well, I need to find what this is from here to there. Okay, I'm gonna call that, I don't know, A. Okay, so I'm going to now figure out what that A is. So I'm gonna do that work here. So I know that A squared plus 9.80 squared. Now, I know that 9.79, when I square that, I need to get 96 because I took the square root of 96 and I got this right here, and that's what I'm plugging in here. So when I take the square root, I should get back that 96. Okay, hopefully that makes sense. If not, just do it on the calculator. It's equal to 12 squared. So I know that 9.79 squared should be, okay, when I go back, it should be 96. And then 12 squared is 144. So now I'm going to do 144 minus 96. That's going to be a squared is equal to 48. And now I'm going to take the square root of 48. And that's going to give me 6.92. I'm going to say, just to round, 6.93. So I know that that A right there is now going to be 6.93. So I'm going to use everything that I know now. Well, first of all, let's talk about the base. I got to add those two in order to find the base. So I add 5 to that and I get 11.92 let's just say 11.93. Okay, so as you can see, I have everything that I need to find the area. So the area is half of the height, which is 9.8, times 11.93, which is the base. So I'm going to multiply that times 9.8 times 0.5, and that's going to give me 58. What I got on my calculator was 58.44. Okay, now some of you might get other numbers. You might get something like this, 58.3 or 58.2. As long as you are close enough, you should be able to get the answer. Okay, when I did the quiz on Canvas, I made sure that that when you plug those numbers, that you were gonna get the right answer, because that is the right answer, you know, when you do that. And let me just verify that for you really quick. Yeah, so if you plug in 58.44, that should be a perfect answer. Okay, so let's go ahead and move on. You are going to do number 11. So good luck with that one. Now let's go ahead and talk about special right triangles. Okay, so in geometry we have what we call two main special right triangles. And we're going to talk about the first one here, and then we're going to talk about the second one later on. The first one is called a 45, 90 special right triangle. Okay, special right triangle. And here's something very interesting about this special right triangle. If you have a 45, so what I mean by 45, it means that wasn't a good run. It means that this right here is 45, and this right here will be 45. Okay, and of course this will be our 90 degree. So let's talk about this right here. So what this tells you, and I do want to go back to something very important here. If you were to Google this and you write 45, 40, 90 triangle, it's actually going to show a lot of pictures that are going to help you with this. So let's actually look for that, because this is a very special right triangle and it's everywhere on Google, honestly. I hate when it doesn't work. It's very difficult because my keyboard sometimes just doesn't want to show up. So I have to turn this into a tablet. Okay, let's see. So if I type in 45, 45, there it is already. Then it gives you this right here. It gives you different pictures that you can use. So I like to use this one right here. So let me explain what this is. So let me actually go back to what I had before, to this right here. So if this right here, it's A, if this is A, Because it's a 45 and a 45, that means that this and this is congruent. So if this is A and that's A, then this right here, this side right here, which is what we call the hypotenuse, is the following. It's A times the square root of 2. Okay, it's A times the square root of 2. So how do we use that? Well, we are going to use that idea in order to figure out what this is and what this is right here. So in here, as you can see, we have a 45, 45. So what I want you to do is the following. I want you to identify, try to ignore this right here because that's going to make it confusing. First of all, try to ignore that. Don't even look at that. And then what you're going to do now is you're going to label your triangle here. So as you can see, this right here is also a 45. Okay, it must be. So this right here, I'm going to label it as A. So as you can see in this angle, if this is A, this will also be A. So that means that this right here is also A. So A is equal to 4. And this right here, which is the hypotenuse, will be A times the square root of 2. Well, what is A? Well, A is 4. So I replace the A with the 4, and I get square root of 2 right there. You guys see what I did there? So let me go back here. Then Y right here will be 4, and this will be my, what we call my X. Okay, so Y is 4. Okay, so it can't be any of those, either between this one and this one, and so it has to be B. Okay, all right, so I'll have you try number 22. Actually, number 22 is a little more difficult. Let me actually do that one for you. So first of all, identify what you have. So let's identify this one as my A, and let's identify this one as my A. That means that this right here will be the following. That will be A square root of 2. Now, A square root of 2, now we have to figure out what A is. But I do know that 5 is equal to A square root of 2. So here's what you gotta do though. You have to divide, because we gotta solve for A now. We're going to solve for A, and we're going to get A is equal to 5 square root of 2. Now, you don't want to have a square root of 2 on the bottom. So what needs to happen is that we need to multiply this by square root of 2. So that when I multiply this, I get a 2 on the bottom. And then I get 5 square root of 2. So that means that A is equal to this right here. So that means that this right here will be 5 square root of 2 over 2. And this right here will be 5 square root of 2 over 2. That is what U and B is. So the answer for this one should be C. Okay, I know that's a little bit confusing at first. It is hard to see it, but hopefully you see it now. Okay, I'm going to have you try number 23 and number 24, okay? All right, now let's talk about another special right triangle. And this one is usually more difficult. Special right triangle. And this one is called a 30, 60, 90. Let me actually put this away. A 30, 60, and 90 degree right triangle. And it works like this. Let me draw another picture. Okay, if I have a 30, 60, 90, and let's say that this one is 60, and this is 30, and this of course will be 90. Okay, if I were to look this up on Google, which if you look this up on Google, you're going to find the following. You're gonna find that if this so the one that is in front of the 30 degrees, okay, what I mean by that is the side that is in front of the 30 degrees, this right here will be A, and the side that is in front of the 60, okay, that will be A times the square root of 3, and the hypotenuse actually is 2 times A. Okay, all right, so let's take a look at this problem right here and let's identify what I have. Okay, forget first about this right here, ignore it because that's just going to confuse you. Okay, identify what you have, label each one of those according to what you have. So the 60 right here is a 60 right there. The one in front is A square root of 3. So this right here will be A square root of 3. After you figured out what A is, the rest is gonna come very easily. Okay, so in here, what I'm saying is that 4 square root of 3 is equal to A square root of 3. I don't know if you can see it, but obviously A is equal to 4. If you don't see it, here's how you can see it better. Divide everything by square root of 3 and divide everything by square root of 3. This and this will cancel. So will this. A is equal to 4. Okay, so A is equal to 4. Now let's label the angles. Let's label the sides. This is A right here, the one in front. Remember, this is 30. This means that this is A as well. Well, we already know what A is. A is 4. That means that this is 4. Okay, this right here, the hypotenuse is 2A. Well, we already know what A is. A is 4. So 2 times 4 will be 8. So I found what I needed now. So n is equal to 4 and m will equal to 8. Okay, if you look at the solutions there, the answer will be D. Okay, so those are what we call 30, 60, 90 degrees triangles. They're challenging, but as soon as you get them, it's pretty simple, guys. It's pretty simple. I'll have you do number 26. I'll do number 27 for you. So once again, I'll even draw it the same way that it's drawn in here. Okay, so if this is the 60, okay, if I look at the picture one more time, okay, the one in front of the 60 is A square root of 3. So this right here will be A square root of 3. Okay, and the one in front of the 30, that one may be A. And this one will be 2A. So that means that this right here is equal to A square root of 3. And I don't know if you see it or not, but you can tell that A is equal to 3. Okay, so A will equal to 3. What does that mean? Well, forget about this and this. This is just gonna confuse you for right now. If this is A, okay, remember the one in front of the 30, it's A, and the one in front of the 90 is 2A. we found what A is. A is 3. Okay, so that means that this right here will be 3, and this right here will be, okay, 2A, it will be 2 times 3, that will be 6. So what we're looking for is, okay, I know the numbers will confuse you, but B is 3 and A will be 6. So A is 6, B is 3, so that would be D. Okay, let's see if I can do one more problem related to that. Okay, I have a couple more to do for you. Okay, number 29, same idea, guys. Now I'm actually just gonna erase this. Remember, this right here will be 2A. This will be considered our A, and this will be considered our A square root of 3. And I'm just looking at the picture that I just drew. Okay, so that means that A is equal to 4. That means that this right here is 4, and this one here will be 4 square root of 3. See how simple it goes? After you get it, it goes pretty fast. Okay, so the answer for number 29 should be C. Okay, this is this right here, and this will be this right here. Okay, all right, let's do number 31. 31 seems a little bit more challenging. Let's take a look at it. Forget about this and this. This tends to confuse people. But let's label this angle here. Remember, a 30 special triangle here. I'm gonna draw it on the side here. If this is 30 and this is 60, then if this is A, this will be A square root of 3, and this will be 2A. Okay? So if I were to do this again, this will be A, this will be my 2A, and this right here will be my A square root of 3. Now, sometimes it's hard to see, sometimes it's not hard to see, but I don't know if you can tell, but A would just be 9 over 2. Okay, so A in this case is 9 over 2. I don't know if you can see that in there, that it's just A is just a number next to the square root of 3. So the number that is next to the square root of 3 is 9 over 2. Okay, so as you can see, A is equal to 9 over 2. This means that this right here is 9 over 2, and then 2 times 9 over 2, those 2 cancel, and then we get 9. So that means that that right there is 9. So let me see. So we have, this is B, and when I erase this, this will be A. So A is 9. Okay. A is 9, and B should be 9 over 2. So the answer should be D. Okay. All right. So hopefully you got that kind of well there. I know it's kind of challenging at first, but hopefully you're able to see it. I'll do number 30, just to give you just one more so you can take a look. Once again, if this is 60, the one in front of the 60 is what we call A square root of 3. So that means this is 30. So this one right here will be just A, and this one right here will be 2A. I don't know if you can see it or not, but square root of 3 and the square root of 3 are right there. That means that this are equal to each other. That means that A is equal to 2. So that means that this right here will be 2, and 2A will be 2 times 2, which is 4. Okay? So in a sense, if I erase this, Y is 2 and X is 4. So that would be B. Okay, so you just have a couple more to do there. I did those for you. All right. The next part is actually pretty simple to do, and you'll see why. This has to do with something called SOHCAHTOA, and hopefully everybody has seen this before when you took the geometry class. I'm gonna write it down, SOHCAHTOA. And usually, you know, teachers spend a lot of time talking about this and researching this, but honestly, we just don't have the time for us to do that. So I'm just gonna explain what it is, and then so SOHCAHTOA relates to right triangles. As you can see, we have a right triangle, and it's used to figure out the angles that is related to right triangles. And right triangles are the triangles that we work with the most. We have right triangles everywhere in the world, and we use SOHCAHTOA in order to find the angles and in order to find the sides of those angles. But for now, we just have to understand what SOHCAHTOA means. Okay, so SOHCAHTOA for so means sine, and sine, okay, it's an abbreviation for that right there, and sine of theta, and what that is the angle. Okay, and now I'll explain that in a second again. Sine of theta is equal to the opposite over the hypotenuse. Okay, so if you take a look at a right triangle, okay, if this is theta, the opposite will be this right here, the opposite of theta, and the hypotenuse is always the one that is facing the right triangle. Okay, so that's all that you see in there. And then we have cosine of theta. And again, guys, I'm doing this pretty fast, I know, because I'm hoping that most of you should know. Cosine of theta is equal to adjacent over the hypotenuse. Now, what is the adjacent? The adjacent is the side that is next to it that is not the hypotenuse. Okay, and those two tend to get confused, but the hypotenuse is always the same one. The hypotenuse is always the same. So we have an opposite angle, we have adjacent, and then the hypotenuse always is the one that is facing the 90-degree angle. And then we also have tangent of theta is equal to the opposite over the hypotenuse. So what do they mean by find the trigonometric ratio of cosine A? Well, here's what it means. First of all, identify the theta. The theta is this right here. It's A. It's that angle A. Okay? So what is cosine of theta? Is adjacent over the hypotenuse. So cosine of A will be adjacent over the hypotenuse. Okay, so all I have to do is identify what's the adjacent and what is the hypotenuse. Okay, like I mentioned before, the hypotenuse is always the angle that is facing the 90-degree angle. Okay, so the hypotenuse in this case will be 39. Now let's talk about the adjacent angle. Okay, obviously it's not going to be this one because that's the hypotenuse, but the adjacent angle is the angle that is next to the A. Okay, that is not the hypotenuse. In this case, the adjacent will be 15. Okay, so that will be 15. Now they are asking us here to simplify this fraction. I could simplify by dividing by 5, or actually by 3, and that's going to give me 5 over 13, and that is what the answer is. Okay, so we are going to use this idea of SOHCAHTOA to find that trigonometric ratio. And then on the next lesson, we are going to talk a little bit more about it. Okay? All right. So, and I'm just really hoping that, you have seen this before and you're not doing this for the first time. Okay, and this one here, it says to find tangent of C. Remember, we have SOHCAHTOA. So we're going to use TOA. We know the tangent of C is equal to the opposite of C and the adjacent of C. So on this one, we don't even use the hypotenuse. So let's identify what you have. So in here we have our C. Okay. The hypotenuse is this one right here because it's facing the 90-degree angle. So this one, let's identify it as the hypotenuse. We are not even going to use that one, but we are going to use the opposite. What is the opposite of C? Well, it's right opposite to it. So the opposite of C will be 16. The adjacent on the other side is the one next to it. Now notice that the adjacent is the number that is next to it that is not the hypotenuse. Okay? So this right here will be 30. All I have to do now is simplify this fraction right here. Okay, when I simplify that fraction and I divide this by each one of those, I could divide by 2 just simply, and I get 8/15, and the answer should be D. Okay? Let's do a couple more. We have sine of x. As once again, we have SOHCAHTOA. So we will be using So it's sine of x is equal to the opposite over the hypotenuse. So first of all, let's find that x. X is right there. Okay, so the opposite of that is the one right next to, or straight next to it. So the opposite in this case will be 12 over, now let's look for the hypotenuse. The hypotenuse is always the one facing the 90-degree angle. So this right here will be my hypotenuse. So this will be 37. Do I find that in here? Yes, it's number A. Oh, I'm sorry, it's letter A. You see how simple that is? It shouldn't take you that long to do these problems. And then finally, let's do the last one here. We're finding sine of A. Remember, we have SOHCAHTOA. Okay, so sine of A will equal the opposite. Uh-oh. Not sure why this thing is not showing. Okay, so sine will be opposite. My battery is running out, that's why I was having trouble there. Let me try to finish this round before the battery dies. Okay, opposite over the hypotenuse. The A here will be that there. Okay, so we need to look for the opposite. The opposite in this case will be 40. Okay, and then the hypotenuse will be always the one facing the 90 degrees. So it will be 41. So the answer for that one will be A. Okay, so those are all the problems, guys. Hopefully you finish those there, and then, well, I'll see you guys on the next video.